like today's revision is more of your time. Okay, so three homeworks are involved for the term test: homework 4, homework 5, and homework 6. Okay, and you also have to know the examples that I showed in class. Okay, so if you have to study for this term test, make sure you know how to do homework 4, 5, and 6. And have you all seen the formula sheet? Yes or no? Right, so there's the formula sheet that you will provide. You can ask me any questions except what question is coming out. Okay, okay, let's look at where you want to start. It's your time. Okay, yes, yes. Yeah, it's going to be 3. I don't intend to give more. Okay. Question? Yes. Five. Question what? Question 4. Okay. So I want to draw your attention to homework 5 and question 4. Okay. So I'm going to get the question out. Okay. So what it states over here. So again, this is focus on to ease your mind. So this work over here, I just want to see. So this is on general motion analysis, and we are going to focus on velocity. Now, anything that you don't really get, just say Eugene, okay? Because I'm looking at my notepad and I'm not looking at you. Just stop me, okay? And if we look at general motion analysis, and we are going to focus on all our analysis that we do is on rigid body. Okay. So the differential drum operates in such a manner that the rope is unwound from the small drum B and warm up. Okay, worn up on the large drum A. If the radii of the large and small drums are R plus R and R, so this section over here is known as our drums. Okay. Determine the speed at which the pulley bucket C rise if the man handle with a constant, highlight over here, constant angular velocity of omega, and we were to neglect the thickness of the rope. Okay. Question like this that will come out, I will ask you to prove that for the velocity is equal to omega over 2 R minus R. Are we clear? But don't you dare in your exam just say Eugene V equal to omega over 2 R plus R without any working. Are we clear? Okay, you have to show me some steps of how you draw. So what do I mean by steps? Okay. So I will expect you all to construct the diagram. Okay, so there are two domains that we're going to look at. We're going to look at the drum. Okay, so we're going to look at the drum. So we're going to sketch the drum. Okay, so this is one of the drum. And then we have another drum. I'm going to align them. Right. So if we were to label, if I were to label this as drum A, you can observe that drum A is bigger than drum B. Okay. So now the question is, what are the velocities? Okay. So at the center is what I call my node, right? So what we have over here is drum A has been worn up. So when it's up, we know that we're going to have a velocity vector for drum A going up. So this is your VA. Okay. So it's been worn up. Now, drum B, okay, it's mentioned that it's going to be unworn. Okay. Now, there's possible, so if I say that VA is over here, right? Point B or drum B, there are two possibilities. You see the dot, I'm going to sketch a different dot. You see the red dot over here, right? And then you see the red dot over here, right? And this question, sometimes you have to do some experiment on your own, okay? For drum B, where is the velocity acting on? Right? You have to write, how is the velocity acting on? Okay. So it can be in point 1, or is it going to be at point 2? Because it does matter. Yes. Right. So when you say point 1, right, the problem is this, okay? Both of them will rotate in the same direction. For this mechanism to work, okay, for this mechanism, in order for this to go up, right, this velocity, this has been pulling up, this has to be what? Coming down, then you retract up. So VA, and this is VB. For it to go up, VA needs to be greater than what? VB. Yes. Yes, both of them are rotating about the same axis wind up by this man. But it did mention, okay, that drum B has to unworn and drum A has to be what? Warm up. Okay, so the only possibility now is this has to be in this direction. Yes or no? Okay, so if you can't visualize this, okay, and especially this is a homework, what can you do? Do an experiment at home. Yes or no? Right? If you can't visualize it, do an experiment at home. That's why this is a homework. Okay. I don't expect you to do this for the term test. Okay. No, sorry. I don't expect you to do an experiment in the term test, but the homework is what we could do. I can't visualize it also. By the way, I was asked this question. Okay. That student over there, I think Wu, asked me that question before. And I was at home doing an experiment on it. Okay, I literally took a rope or took a string, okay, and I wound and I saw physically what happened. Because if these two were to go up, what will happen? If these two were to go up, what will happen? You have slack, right? And it did specify one has to be what? It did specify what? One has to be what? Unworn. The other one has to be what? Worn up. It did specify that, okay? It's normal not able to see this. I did not see it at all. I'll be frank until I start like, okay, how does this actually work? And then I get to see it. So sometimes it's good to do some experiment. Okay, so from here we know. So I will call this my point A. Okay, I'll call this my point A, and I'll call this my point B. Okay, so we construct this and we are aware. What are we aware? That the handle is rotated omega. Now, you want to guess what omega is? Omega going clockwise or anti-clockwise? Anyone? Yes, clockwise. Why is it clockwise? Right? So when it's rotating clockwise, VA then will be going upwards. When you come over here, omega is over here, VB then is going what? Downwards. Are we clear? Okay, don't memorize all this. Just look at your factors. Okay. So we are given omega. The next thing is we have or I have not a clue. Okay, so unknown for now is my VA and what? And VB, right? So these are unknown. But one thing we know for sure, we know that velocity at naught is equal to what? 0. Yeah. We know that velocity at naught is equal to 0. Okay, so now that's all we can do with the drum. This problem is unique in the sense that it's a multi-body problem. Okay. What do I mean by multi-body? It's related to the what? The pulley. Okay. So now we're going to put in some geometries now. Okay. So the small one, this is R. And then the big one. Okay. So drawing a diagram like that, you get 1 mark. Okay, I repeat again, drawing a diagram, you get 1 mark. Because this shows that you know how to what? Synthesize the problem. Are we clear? Okay, so don't ignore. Yes. Huh? Don't know yet. I haven't started to solve yet. Yeah, you can. Okay. But I don't know yet because I don't want to use just omega r. I want to use it as a vector form. Okay. Now I know when you say v equal to r omega, that is very commonly used in instantaneous center. Most of the time, stick to vector form. Are we clear? If it's instantaneous center, okay, you don't need to stick to vector form. Okay, my advice for you, the problem like this, stick to vector form. So from here, we look into the pulley now. Okay. So by looking at the pulley, okay, looks like this. Just going to sketch this out.